Hello, Rasmus Bro from Chromaf here. I wanted to talk a little bit about limit of detection. I think I have a nice example. We made a data set decades ago, I think. It was apple wine fermentation. And at that time, the data were measured by GCMS and the data was analyzed into peak tables using ChemStation. And at that time, we found 21 metabolites, and one of them, actually, let me plot the data, was acetone. Let me just take a look here. Okay, this is ethyl acetate. Plotted versus time. I'm just going to plot on a linear index. We can see 3 different fermentations. Acetone, there we are. Okay, so that's the results we get, or got at the time. And what you can see here is that there's a certain threshold below which all values are set to 0 because it's below limit of detection. In ChemStation, you have to be able to see the peak to integrate it. Which makes sense, but the thing is, in Paradise we don't actually have limit of detection. We quantify in all samples. Now you may afterwards decide to define a limit of detection, but all analytes are quantified in all samples. That's simply just built into the way that these things are analyzed. So there is no limit of detection. I know some analytical chemists will disagree now. So yes, limit of detection exists, but that's for when you have a specific purpose in mind. The actual method, the Parafact2 model that is used to integrate the data, will quantify all the chemicals in all the samples. So let's take a look at the original data in Paradise. And here's the peak, the interval where we find acetone. I fitted a model, and as is usual in Paradise, several different alternative models will do the job, but this one looks nice. It's the red compound here. So let me just, for the sake of the visual appearance, remove the other ones. Oh no, it's the green one, sorry. It's this one. This is acetone. We can look it up in NIST and see if that makes sense. And indeed, we get a fairly good match. So this is acetone indeed. Now, I want to show you corresponding to this plot, the actual quantification in the different fermentations. We can just click here in this plot here and have a look. Might be a little bit hard to see, but I hope you can see the green crosses here. Now there's actually 2 fermentations of one organism, another one and another one. They're organized slightly different in the other data set, so they appear on top of each other. But that's not the important point. The important point here is that, well, actually these curves look nicer here, but the main point is, there's a sample here that has a 0 concentration, but all of these are above 0. They're below limit of detection, but we're still quantifying them. And this is potentially very important. In many cases, when we do untargeted analysis, we're looking for patterns in the data that are indicative of some things. And the absence of an analyte in a sample can be indicative of certain things. So having accurate quantifications, even at low concentrations, can be important. In any case, it's hard to argue that it's better not to quantify them. Anyways, we do quantify all chemicals in all samples. Thanks.